Prior to today, you worked on simple interest, which uses the formula I equals PRT. I is interest, P is principal amount, or how much you are investing or putting away in savings. R is the rate of interest written as a decimal. And remember, if you have the rate 25% and you want to change that to a decimal, you simply move the decimal over 2 places. So 25% would be 0.25. Yes, I do want to see the 0. Anytime you have a decimal, I want to see a number 0 in front of it so that I know that you're giving me the number 0.25. T is the amount of time in months or years. Now, typically, you're going to see it in years. Your parents give you $50 for Christmas and tell you that it can be invested to earn simple interest at a rate of 0.5%. If you leave the money in that investment for 5 years, how much money will you have? Okay, so we're using I equals PRT as our formula. So we want to know the amount of interest so that we can add that back to the principal to find the total amount of money we have saved. So we first put away the $50 for savings. We also are getting an interest rate of 0.05%. 0.5%. So we need to move the decimal back 2 places, which is going to give us 0.005 as a decimal equivalent to 0.5%. And we multiply that by the amount of time, in this case 5 years. Yes, that's a lot of 5s, but that's all right. So we have 50 times 0.005 times 5 gives us a whole I equaling $1.25. Now, we have made $1.25 in interest on the $50 that we originally put away for savings. So altogether, we have saved $51.25. Now, this formula represents the amount of money that you will have after 1 year. I equals PRT, where T represents 1 for 1 year. Well, assuming that we understand that T is representing 1 for 1 year, we could then say that I is equal to the principal times the rate times 1 for 1 year. Well, the 1 will simplify out, so that really just leaves us a annual balance would be I equals PR. Now, the annual balance is the principal plus the interest. The principal plus the interest. So how much would you earn after 1 year if you started with $2,000 and earned 12% interest? Well, we have 1 year that we're looking for, so we know that T is equal to 1. So it's going to simplify out of our equation. I is equal to PRT. If I plug a 1 in for T, it goes away. So we simply need to know the principal times the interest. Principal times 0.12. Well, our principal is 2,000, so 2,000 times 0.12. Now, when you multiply 2,000 times 0.12, you get $240. $240 is the amount of interest. Now, one of the shortcuts that you will end up working with is recognizing that 12% is the interest. 100% recognizes the amount that I've invested. 100% of that money. If I add 12% to 100%, we end up with 112%. Where we can move the decimal 2 places over, and we end up with a 1.12 as a rate. Now, since this is our decimal rate that we would plug in, we could then multiply 2,000 times 1.12. Go ahead and do that in your calculator. 2,000 times 1.12. And notice you get $2,240. Well, why did we end up with a different answer than what we had before? Before we were just multiplying by the rate alone. Now we're multiplying by 100 plus 12%. 100 allows for this 2,000 to get calculated into the solution. So, in general, the amount of money after 2 years can be expressed by the following formula, which multiplies what you have after 1 year, which we just said was 2,240, by another 1 plus our rate. So how much money would we have after 2 years if we started with 2,000? Well, that would be like us saying $2,000 times 1 plus 0.12 times 1 plus 0.12. Notice the first time I multiply it, I will get the interest after 1 year. The second time I multiply by 1.12, we're going to get the amount of balance I have after 2 years. And so that ends up with $2,508.80. Notice that we've now multiplied the principal times 1 plus r twice. That's important because, see, we've multiplied the principal times 1 plus r times 1 plus r. Well, we could rewrite the 1 plus r times 1 plus r as 1 plus r squared. Extending this, we developed the formula for the amount of money in the account at the end of t periods. The formula below should look very familiar from our word problems with appreciation. Remember when we did appreciation, we had the function f of t is equal to a sub 0 times 1 plus r raised to the t power. See the similarities. Our output or our solution is equivalent to our principal or our starting value. A sub 0 always represents our starting value. So, a sub 0 times 1 plus r raised to the t is simply a variation of the same formula. Well, this is what you typically see when you're dealing with appreciation anywhere other than problems that are dealing with interest. Or calculated interest, I guess is a better way of stating it. If you initially invest $500 and you earn a 2% interest, how much money will you have in 5 years? So we have a principal of $500. The amount that we would have is 500 times 1 plus the rate. Well, that's 2%. So 2, move the decimal over 2 spaces. 0, 2, raised to the t, and our t is 5 years. So we have 500 times 1.02. I'm missing a decimal there, aren't I? Raised to the 5th power. And at this point, I just recommend that you plug that into your calculator. 500 times 1.02. Raised to the 5th power. And you will end up with something like the amount now in your balance is $552.04. Suppose your interest is calculated multiple times a year. A modification needs to be made to our formula to account for the compound interest. Now, this understanding of compound interest is going to be very important for you. that's being done more than once a year. Suppose it's done n or any random number of times in a year. While you do not get the full rate each time, you do get to compound more frequently. So notice in our formula down here, our rate is getting divided by the number of times we are compounding the interest or adding the interest in, so that it gets so that our future interest is based on our increasing principal. Well, then we raise it to the nth power, the number of times we're compounding interest, times our time. So we have $7,000 invested at a rate of 3% compounded quarterly. Well, what does compounded quarterly mean? Well, quarterly means 0.25, 1/4, or 4 times in a year. So we want to write our interest function to model this situation. Function would be f of t is equal to 7,000, which is our starting value, times 1 plus 0.03 raised to the, divided by 4, because we're taking our compounding quarterly, raised to the 4t. Okay. Well, now we want to find the balance after 10 years. Well, the only difference is we're plugging in a 10 for t. So f of 10 is equal to 7,000 times 1 plus 0.03 over 4 raised to the 4 times 10, which is 40th power. And so you can plug all of this into your calculator. 7,000 times 1 plus 0.03 divided by 4 raised to the 40th power. And you will end up with a f of 10 is equal to 9438.44 dollars. That's not a bad return. Yeah. Find the value of $15,000 invested in a mutual fund that earned an annual percentage rate of 8.25% compounded monthly for 8 years. So I'm going to start with a function. F of t is equal to 15,000, our starting rate, times 1 plus, move our decimal over 2 places, 0.0825 divided by our compounded monthly. Well, how many months are there in a year? There are 12. Raised to the 12 times 8, or you could say 96th power. So again, we're going to plug this information straight into the calculator. 15,000 times 1 plus 0.0825 divided by 12 raised to the 96th power. Now 96 seems really large and it feels like we're making a very big number, but notice we have a small decimal here getting divided by 12, making the number even smaller. So it's not like we have a rate that is super large. So f of 8 years is going to be equal to $28,956.42. All right, I want you to take an opportunity to solve the following two. When you come back, I'm just going to give you the functions. You can plug both functions into your calculator. All right, first function, f of t. Oh, we got a t. Sorry, let's try that again. F of 8, because we know the value of t, is equal to 15,000 times 1 plus, let's move our decimal over 2 places, 0.0325 divided by, we are compounded monthly, So we're dividing by 12, raised to the 12 times 8. All right, which again is 96. All right, now down in our bottom one, I'm going to write the formula above the problem. So f of 8 years is equal to 15,000 times 1 plus, and we want to know our rate as a decimal, so move it over 2 places, 0.0345 divided by, well, now we're compounding yearly. That's just once per year. Raised to the 1 times 8. Our end value is 1. Our time is 8. And now that you have the two equations, you can plug both into your calculator, find their value, and determine which one is going to be a better deal for your money.